Proving triangles congruent, day 3. So let's review what we have learned. So we have learned that we can use the fourth theorem or postulate to prove the two triangles are congruent by side, side, sides, side, angle, side, angle, or angle, angle, side. Okay, today we will introduce you to a new postulate, and this only applies for if you have two right triangles, right? The theorem is called HL. So H stands for hypotenuse, and L stands for the leg. So if we have two right triangles, if the hypotenuse are congruent to each other, and one of the legs are congruent to each other, then the two triangles are congruent by what we call HL. And remember that this only works for right triangle. Okay, so let's go through our example 1. Given that segment BC is congruent to segment DC and segment AC is congruent to segment EC, prove that triangle BCA is congruent to triangle DCE. Right. So then before we start to prove, let's mark up our diagram. Right. So we're given that segment BC is congruent to DC. So go through the diagram, we mark that BC and DC are congruent. So we have the sides is congruent, and we have segment AC is congruent to segment EC. So AC is congruent to EC. So we have a size. So then we need we learned before that these two angles are congruent by vertical angles. So then we have angle, angle. So then we can prove that by side, angle, size. Right? Okay, so let's go through our two-column proof. So the first statement will always be the given. So we're saying that segment BC is congruent to segment DC, and segment AC is congruent to segment EC. And number 2 said the vertical angle, so we say that angle BCA is congruent to angle ECD. Remember that the order where you write this is important. And then number 3, we say that triangle BCA is congruent to triangle DCE by side, angle, size. Okay, so then in order to do the proof, it's easy if you mark up the diagram first, which gives you which theorem we need to use. Okay, let's try example 2. We're given that segment JK is congruent to segment LK. So we're going to JK congruent to LK, so we have a size. And segment JM is congruent to segment LM, so JM is congruent to LM. And here, when we look at our diagram, notice that KM share for two triangles, so then we have this segment is congruent, so by size. So we can prove that these two triangles are congruent by size. So number 1 is always the given. So then you would write JK is congruent to LK, and JM is congruent to LM, and the reason is given to us. And number 2, well, reflexive, we can say that KM is congruent to KM. And then step 3, triangle KJM is congruent to triangle KLM by size. Okay, example 3. Given angle G is congruent to angle I. So then we mark that angle G is congruent to angle I, so then that's the angle. And segment HF bisect the angle GFI. So this is the angle bisect, so that means that these two angles are also congruent. So we have angle and angle. But notice that FH shared by the two triangles, so then they're congruent by size. So then we see that angle, angle, size. So number one will always be the given, right? So for number two, we say that angle GFH, so then let me use a different marker. This is GFH, it's congruent to IFH. Well, we know that it's congruent because of the angle bisector, right? So then it's a definition of angle bisector. And for number three, reflexive, so we say that segment FH is congruent to segment FH. And the last step is to prove so triangle GFH is congruent to triangle IFH by angle, angle, size. Okay, example 4. Given angle M and angle Q are right angles, so then N and Q are right angle, and we're given that segment MO is congruent to segment PQ. So saying this is a right triangle, so this is our leg and our leg, right? So for number one is the given, and number two, we're saying that triangle OMP and triangle PQO are right triangle, right? It's because we're given that angle N and angle Q are right angles. So then here we're saying that this is a right angle and this is also a right angle. And number three, reflexive. Well, we know that OP is congruent to OP. So say that OP is congruent to OP, right? And then this is a right angle, so then this is our hypotenuse. And well, NO is congruent to PO. It's given to us, so then we write another given. And step 5, triangle O and P is congruent to triangle PQO by HL theorem, hypotenuse and leg, because we're given that these are right angle. Okay, so when you guys do proof, it's easier if you mark up your diagram first, right? And for number 5, we're given that segment ST is parallel to segment RU. So then ST is parallel to RU. So we can do this to indicate that they're parallel. And segment SR is parallel to segment TU. So then this is SR and TU. They're parallel. So number 1 is given. Well, when we're given that ST and RU are parallel, that means that this angle and this angle are congruent. So then this angle is called URT is congruent to angle STR, because of if lines parallel, then the alternate interior angles are congruent. And then step 3, let me use a different marker. So we're using this. So SR is parallel to TU, then is given. And SRT, so then SRT is congruent to UTR. So then these two angles are congruent because of the same reason for number 2. Right, so we say that if two lines are parallel, then the alternate interior angles are congruent. And then step 5, we're sharing the same line, RT and RT, so we say that segment RT is congruent to segment RT, and this is reflexive. Right, in step 6, triangle SRT is congruent to triangle UTR. Well, when we look at that, we see that this is angle, psi, angle. Right, so then will be angle, psi, angle. Okay, number 6. Given that angle W and angle Y are right angles, so then we mark angle W, angle Y are right angle, and segment VX is congruent to segment ZX, and these two are congruent, and so this is right angle, so this happens to be the hypotenuse, and X is the midpoint, so X is the midpoint. Right. Okay, so then this is given, and so then those are right angles, so we can say that triangle VWX and triangle ZYX are right triangle because the definition of right angle. And number 3, segment VX and is congruent to segment ZX, and X is the midpoint of segment WY is given to us from up here. Okay, and then X is the midpoint. We can say that WX, segment WX is congruent to segment YX, because X is the midpoint, so that means that these two are congruent. So we have the leg. So step 5, we can say that triangle VWX is congruent to triangle ZYX by hypotenuse leg. Okay, remember that in order for us to use this theorem, they must be right triangles. Right, so that's the end of the note. So your assignment for today is on worksheet 3C.